Another group of organic molecules that we have to know at your level are what we call aldehydes as well as ketones. I know that sometimes there's often a confusion in terms of identifying an aldehyde as well as identifying a ketone, because students tend to think that they look similar, but they actually don't. And I hope at least by the end of this lesson you are able to distinguish between the two. So we're going to start off with aldehydes. So aldehydes have a functional group, and that functional group we call it is the what we call the formyl functional group. So that is an aldehyde. Just gonna write AL there. Ketones, on the other hand, have what we call a carbonyl functional group. And what do they look like? So so this is a ketone. So the 4 mile functional group normally looks how you identify it. So you see a carbon at the end of your molecule bonded to an oxygen. That's a double bond as well as a hydrogen. With a ketone, this carbon double bond, you find it in the middle. So it's in the middle of your chain. So you might have a carbon on this side as well as another carbon on the other side. And then you have this carbon there in the middle will be bonded to what is it? To an oxygen. There will be that oxygen double bond. So look at the position. The position of this 4 mile group is at the end, either to the left or to the right. And then for the ketone, right, aldehyde. For the ketone, the position of the carbonyl functional group is actually situated in the middle, right? And then when we name when we name aldehyde, we have to end that naming with I don't know what is it now, al actually, it's not now. So our suffix at the end is supposed to be al. For this one, it's going to be, for ketones, it's just going to be on, right? Okay, let us take a few examples of what we've just said. So let us first start off with aldehydes and take maybe an example. So an aldehyde with 3 carbons in it. And like I said, to identify it, this carbon with a double bond plus an H would be at the end. So because it's 3 carbon, we know that it's going to start with propan. Because it's an aldehyde, it's going to finish with al. So this molecule is actually propanal. And then if it was 4, let's draw it, let's not be lazy. If it was 4, this carbon with the double bond, let me draw it on the first carbon from your left. So let's say this double bond was here, right? So there we are. So we identify that it's an aldehyde because of this 4 mile functional group, and it has 4 carbons on it. So it's going to be butanal because it is an aldehyde. Let us take the case of a ketone quickly. Okay, so on this side, let us now talk about ketones. And let's take a ketone with 3 carbon atoms still. 1, 2, 3. So that double bond cannot be on this carbon or this carbon because it's a ketone. So it will be on this carbon here. So it cannot be on the outermost carbons, only on the innermost carbons, right? And we said when we name it, it's going to end with on, right? So there we are. So because it's 3 carbons, it's still going to be propan. it's a ketone, it ends with an one. So this is going to be propanone. Let us take an example. Maybe let's say we have 5. Let's put it here. Okay, so you're gonna forgot to say something before we move on. So this is something that you should have noticed. For this, somebody might say, okay, I can start labeling my carbons. I have tissue all over me now. I can start labeling my carbons from 1, 2, 3. And if I name this, I can already say this is propan, because the thingy is on the C double bond is on carbon number 2. It's going to be propan 2 one. The reason I didn't write it, it was because it can only be on the second carbon if there are 3 carbons involved. So it wasn't necessary to include the 2. So when you write propanone, essentially the person should know that this double bond is going to be on the second carbon, right? It can't be on these 2 outermost carbons. But now let us take a case of, let's say we have 5 carbon atoms and we put our double bond there, C double bond there. Let's just draw this quickly. And then we will have to start naming. So it really doesn't matter. So we have to start naming. Carbon 1 will have to be the carbon closest to our functional group here, our carbonyl functional group. But you can see from both sides it's the same distance. So you can just say 1, 2, 3, 4, 5, right? And then when we write it down, we know it's 5, meaning it's going to be pent. Pentan actually. Pentan. The C double bond, that carbon is carbon number 3. 3 own. So that will be its IUPAC name. I'm tempted to do one for, what is it? Butanone. But it's fine. I think this is enough, especially for today, because I don't want this lesson to be too long. So, like I mentioned, with ketones, notice that the position of the C double bond is always inside. It's not on the outermost carbons. So when the outermost carbon to your left or to your right, it can only be on the innermost carbon. So even in here, this double bond, for it to be a ketone, it could either be here or here or here. If it was here, then it would become an aldehyde. And that should also tell you something. Let us take these 2 for instance. Let us take propan 2 or propanone as well as propanol. Let us write their molecular formula. So to write their molecular formula, we say, okay, we have 3 carbons. How many hydrogens? 1, 2, 3, 4, 5, 6. 6 hydrogens and 1 oxygen, right? Do the same thing for propanone. We have 3 carbons. How many 1, 2, 3, 4, 5, 6. 6 hydrogens and 1 oxygen. So there's something that you're noting. Their molecular formula is the same. However, they belong to different functional groups. This one belongs to the 4-mile functional group, and this one belongs to the carbonyl functional group over there. So these are what we call functional isomers. We've already spoken about functional isomers in the last lesson when we were comparing a carboxylic acid as well as an ester. So that's also another important thing that you should know about. And this actually brings us to the end in terms of all the organic molecules that you're supposed to know. So remember, we started with alkanes, hydrocarbons, so we had our hydrocarbons, which were our alkanes, alkenes, alkynes. So those are compounds only with carbon and hydrogen in it. And then our discussion went on to, I have a terrible handwriting. Then we moved our discussions to haloalkanes, which have halogens, which have alkanes with a halogen substituent. It can be 2 or more. Then we went to alcohol. They have that functional group of OH, or the hydroxyl group. And then we moved our discussion to carboxylic acids, esters, and now we're talking about ketones and aldehydes. So those, in a nutshell, are some of the things that you might be tested upon. Those are the a few organic molecules that you have to know. You have to know how to label. You have to know how to draw their condensed formula. You have to know how to write down their molecular formula. You have to know how to draw their structural formula. You have to know how to, especially for your hydrocarbons, find the general formula. And all of that we've already discussed in the previous lessons. So this brings us to the end in terms of discussing organic molecules. And in your final paper, in paper two, this actually, your organic molecules actually contribute a lot. In the next few lessons, we're gonna focus on what is it, organic reactions. So now those organic reactions that we're gonna be considering is gonna be your addition, elimination, and substitution. So just make sure that you watch out for those videos.